Well, this section goes back to the sum of a finite arithmetic, a finite geometric, and an infinite geometric series from recent concept. So you just need to be able to kind of recognize what type. This is arithmetic because it's a linear equation. And so we have all the information we need here. It goes from 1 to 5, so that means n is equal to 5. So I got a 5 over 2, and then a sub 1 is found by plugging in 1 into the equation. Plug in 1, I got 10 times 1, which is 10, plus 2, which is 12, plus the last term, and I find the last term by plugging in the top number. And 10 times n, or 5 in for n, 10 times 5 is 50, plus 2 is 52. So you take the 12 plus 52, that's 64. 5 over 2 times 64 is 32 times 5, which is 160. Okay, you can also plug in a bunch of these things. 12, you'd end up with 12, 22, 32, 42, and 52. Add them all together, you should end up with the same number. And in some cases, this equation is just kind of a beast anyway. It's a lot to have to kind of think your way through, but that doesn't mean it's beyond us. A sub 1 is the first term. You plug in 0, it wipes out this thing, and your first term is 10. Okay, but then it's a matter of doing 1 minus the common ratio raised to certain powers. The common ratio we can see is just that thing that you're multiplying by each time. So it's 1 minus 2 raised to the, from 0 to 4, there's 5 terms there. So it's 2 to the 5th power. And then we're dividing it by, in parentheses, 1 minus the common ratio. 1 minus 2, close the parentheses. So it's 310, and just for the sake of doing it, I'll show you how that works if you go through the manual operation, because I would almost recommend that in some cases with this equation. If you don't have that handy dandy trusty dusty calculator that I just showed you, it might even be more difficult to use to try and do the equation and do it right. But if I plug in 0 into this, 2 to the 0 power is equal to 1, and 1 times 10 would give me 10. That's the first term. If I plug in a 1, 2 to the first is 2, times 10 is 20. And I'll do this one more time and show you. You plug in 2. Now I've plugged in 1, and then I plugged in 0, and then I plugged in 1. So now I'm plugging in 2 into the end. 2 squared is 4, and 4 times 10 is 40. But let's just remind ourselves what this equation is all about. This says each time I'm going to multiply by 2, and we see that here. 10, 20, 40. The next number, if I plugged it in, great, but the next number I plug in is going to be 80. Or I'm going to plug in a 3 to get 80. That's plugging in 0, plugging in 1, plugging in 2, plugging in 3. The last thing I plug in is the 4. And that's going to give me a 160. And just to recap, 2 to the 4th power is 16, and 16 times 10 is 160. If I take that 160 and add 40, that's 200. And 200 plus 80 is 280, plus 20 is 300, plus 10 is 310. So you can see how it worked. You see that it worked. There you have it. And I would almost recommend doing that for various other problems here. You could do that with this one, and arithmetic for the next one, and so on. But lastly here, let me just do this. A sub 1 is the first term. That's 1/2. Over 1 minus the common ratio. What are we doing to get from here to here? I'm cutting it in half each time. So 1 minus 1/2. So this is 1/2 over 1/2, which is equal to 1.